Good evening, Sir Ivan. We are the group of Mechanical Engineering. In this presentation, we're going to talk about different type of forces. Axial force, bending force, shearing force, and torsion force. In this part of the presentation, I'm going to talk about objects which experiencing axial force in line with our course, Mechanical Engineering. So, first, let's define the meaning of axial force. Axial force is generally defined as the force acting along the axis of the component or assembly. For example, consider a cylindrical building column, square column. Every truss element of the structure is designed to take only axial force, either tension or compression. So, we choose car axle as an object in mechanical engineering that experiencing axial force because first, axle or car axle is a rod around which a wheel moves or rotate. The front wheels of your car sit on an axle, turning around it as the car moves. So yan nga, yung car axle daw, yan yung parang nakadikit sa gulong na nagde-declare kung saan direksyon siya mapupunta. So, yun nga yung napili namin. Yung axial force ng axle, depende kung saan liliko yung kotse. Pag pa-right, edi pakanan din yung axial force ng kotse. And next one is the car shock absorber. Yan yung car shock absorber yung siya yung parang sa mga humps. Siya yung nag-absorb ng shock pag dumadaan yung kotse sa humps, which is nako-compress yung shock absorber ng kotse kapag kapag ito ay dumadaan sa humps. So yun nga, naka-experience siya ng axial force. So we're going to the next slide, which is bending force, that will explain by RENEE Julienne. In this part of the
Bending force is a load that is applied to a portion of material certain length from a fixed position. Bending forces are applied in many everyday situations. Someone who is climbing a ladder, leaning against a wall, is applying a bending force not only to the fixed ends of the ladder, but also to the person on the ladder. Another example is a kid wobbling and playing with their ruler in a to and fro motion. Another common instance of a bending force is a wrench turning a bolt. If the bolt is damaged, a bending force applied by the wrench can create a failure due to torsion at the bolt. There are also many industrial situations where a bending force is applied. A pipeline being lowered or taken out of the ground can undergo bending forces.
In this part of presentation, we'll talk about shearing force, which is applied in mechanical engineering. Shearing force in mechanical engineering can be attributed to its different tools and also machines. So what is shearing force? Shearing forces are unaligned forces pushing one part of a body in one specific direction and another part of the body in the opposite direction. So this force, specifically said unaligned force, not aligned with each other, because when it is aligned, it tends to be called a compression forces. So what happens when forces are unaligned? It creates an object which is under the pressure of shearing force to be cut off or tear apart. So an example of this, the item that is an example of this is a bolt cutter. So a bolt cutter, if you're familiar with this tool, it uses to cut bolts when on locks or even on hard surfaces. Another another application of it is on shearing machine. So a shearing machine in industry is used to cut metal sheets. It's also the same principle, two forces, unaligned forces, and it will cut sheet by two parts. The other one example, the scissors, will be discussed by Mr. C.
A good example of shear force is seen with a simple scissors. Since scissors slide again with each other and move in an opposite direction.
In this part of the presentation, I'm going to talk about a few objects which experience a type of force known as torsion. Now, this type of force is what affects objects to turn on a certain point. The objects I'm going to discuss about are a screwdriver, bolts, a spanner, a torque wrench, and finally, a tower crane. Firstly, a screwdriver is one of the most common tools one would find in one's toolbox, since it's a tool that aids in securing things together. But how exactly does it work? The way it works is by applying a force perpendicular to the center of the top of the handle. As you can imagine, the distance where the force is applied is the radius of said top. This will cause it to turn, in which the force is known as torque. Next, we have the bolts. These legs secure objects together. They may be fastened by a screwdriver or by the next two objects, which are the spanner and the torque wrench. But before we get to them, a bolt experiences the same amount of torque that is produced by either tools. The tools used to secure them depends on how much torque is needed. Next is a spanner. Now this tool works the same way as to how a screwdriver does. However, the distance from the pivot point is greater. This is what usually is used to secure heavy loads. Therefore, the torque produced by this tool is far greater than that of a screwdriver. Next is a torque wrench. This tool is a close relative of a spanner, but this is a far more specialized tool. See, securing loads in place with as much force is a surefire way of not worrying about it in the long run. However, the bolts used for such tasks tend to wear down quicker. This is due to the excessive torque applied to the bolt, which permanently deforms its teeth, making it loose. A torque wrench is used to apply a certain amount of torque on a nut or bolt, as well as measure the amount of torque applied while fastening. Lastly, we have a tower crane. This is usually seen to help out in building tall towers by moving heavy loads to certain distances or heights. The way it works is similar to a seesaw, but compared to that, this is a balanced seesaw. If it were to just carry a load, it would tip over itself. That is why it has counterweights opposite to the boom, to counteract a moment of a force. A moment of a force is what causes a body to rotate about a fixed point, and that is not what you want to ever see a crane do. That is all. This is the Mechanical Engineering Group. Thank you for listening.